Welcome back. We're going to begin our study of Unit 5 as we continue our work on Math 109 topics. Unit 5 involves some concepts that you might have met previously in your learning experiences, notions of prime numbers, composite numbers, greatest common factor, least common multiple. So there's a lot going on. I don't think it's particularly difficult. It might have been a while since you've done this. So why don't we go ahead and fire up this PowerPoint and see what we can do. All right, we're sharing. And let's start from the beginning. Okay, so you can see Unit 5 takes content from Chapter 4 in your textbook. I won't do a whole lot of different things. However, I do tend to say I find greatest common factor rather than greatest common divisor, but that's probably not the biggest thing for us to worry about. All right, so there's your overview slide. What's going to go on in Unit 5. Chapter 4 serves as a reference point. Chapter 4's got 3 sections we'll look at. We'll look at what it means for a number to be prime versus composite. We'll look for methods to try to find out whether a given number is divisible by 2 or by 3 or by 4. Some of the things that you probably have done in the past. Your author does include a test for divisibility by 7, I believe, and also by 11. I don't think we're going to get into that because I quite frankly think it's a little more problematic than it's worth. All right, more overview stuff. So you got 4-1, more divisibility is the key, and you will probably see a symbol that you might not have recognized from previous learning. So that's kind of cool. Section 2 gets primes and composites fired up, and then last section, section 3, gets us into greatest common factor and least common multiple. Some objectives for you to read, and you already know that I get annoyed if people read that screen to me, so I'll let you have a moment to check it out. Some more objectives for section 3. All right, it's time to begin section 1. We're going to talk about divisibility. So we'll look at basically the interchange between several words, the idea that a number is divisible by something in tandem with the fact that we'll say that that number has a factor, or maybe something is a multiple of that number. So what we want to realize is that these phrases can be used kind of interchangeably, and they have some connections. So I put a slide in here for you just to say, all right, well, if this is what I know, I can say the same thing a lot of different ways. So we know that 15 is divisible by 5 because it's actually no remainder on the divide. It divides 3 times evenly. We could also say that 5 is a divisor. It's a divisor of 15. 15 is said to be a multiple of 5. 5 is a factor of 15. And the last one on there says 5 divides 15. We will see a symbol that you and I will use for the phrase divides, and that might be new to you. And there it is. All right, it's kind of a vertical bar. You see it there. And the example on the screen says, we might write 10 divides 50 to note that 10 divides evenly into 50. So when we say it divides without a remainder. In effect, there is some whole number that we could multiply by 10 and get a result of 50. And that's what you see on the formal definition. If we say that A divides B, then there is some value such that we multiply that value times B and we would get the result for A, where that value has to be a whole number. All right, some examples for us to consider with our new friendly symbol. First one says 4 divides 20, and we're just supposed to say, yeah, we agree or we disagree. So I think that's probably true. 4 divides evenly into 25 times. The second one's just being cute. 0 divides 6. Sorry, division by 0 is undefined, and it wouldn't matter if that was a 6 or a 3,000 or 142. That guy's false because you and I can't divide by 0. The last one's kind of sneaky. It says 0 is odd. By definition, in most textbooks, 1 is odd, and between any 2 odds, you'll find an even. So if 1's odd, just to the left of 1 on the number line would be 0, and that would then, by definition, be even. So we'll say that 0 is odd is false. We'll classify 0 as an even number. Number 4 says 8 divides 2. No, it doesn't. 8 divides 16. 8 divides 40. 2 divides 8, but 8 does not divide 2, so that's false. Number 5, 4 divides 8 times n, where n is any whole number. Now, this is kind of cute because, if you think about it for a bit, 4 divides 8. So no matter what no matter what n is doing to that piece of arithmetic, that piece of multiplication, 8 times n, you already know that 4 is going to divide 8. So no matter what n is, 4 will divide the product of 8 times n. So that one's true. Little algebra flashback for you. X to the third divides x to the fifth, where x is any non-zero whole number. And that happens to be true. All right, x to the fifth has 5 factors of x. And if somebody says, can I pull out 3 of those factors? Yes, you can. So number 6 is true. So a little bit of playing out here with the divisible sign. Now, in math, you've seen this before. Oftentimes we'll take a symbol and we'll slash it, and that simply introduces the negation of that symbol. So problem 7 accurately would be read, 8 does not divide 2. And again, we're basically trying to decide whether it's a true or a false statement. I don't think 8 does divide 2. 2 divides 8. 8 does not divide 2. So problem 7, as you see it, is true. 1 divides n, where n is any whole number. 1 divides n, where n is any whole number. I believe that to be true. This last one's kind of nifty. 3 does not divide the product of 5 times 7 times 9 times 11. And then just for hoots and hollers, we'll add 1 to that piece of arithmetic. So just for a second, if you take away the add 1 idea, 3 would have divided 5 times 7 times 9 times 11 because 3 divides 9. So as soon as you take 3 and then you say, well, dang, it's going to divide 5 times 7 times 9 times 11. But if we add 1 to that, 3 will not divide that sum. Had we added 3 instead of 1, 3 would have divided that piece of arithmetic. Had we added 6 instead of 1, 3 would have divided that piece of arithmetic. So it's kind of a sneaky problem on number 9. The correct answer is it's true. 3 will not divide that sum. All right, so again, some words for us to ponder. If we know that B divides A, we can say correctly mathematically that B is called a factor of A. B is also referred to as a divisor of A. We can correctly identify A as a multiple of B. Now, these divide theorems that you're going to see coming up, I don't know that, they're not heavy. And if you think about it a little bit logically, I think you'll be okay. For any whole numbers A and B, if B divides A, then B will divide any number times A, where that any number is any whole number. So again, we kind of solved this on a problem earlier. If B divides A, B is going to divide something times A no matter what the something is. All right, so here we go. We're going to say if D divides A and D divides B, then D will divide the sum of A plus B. If D divides A, but it doesn't divide B, then it won't divide the sum of A plus B. If D divides A and D divides B, and A is greater than or equal to B, then D will divide the difference of A and B. If we were going to contemplate negative numbers, and we haven't really done that in this course, that would take the restriction away for A having to be greater than or equal to B. The only reason that restriction's in there is so that we don't have negative numbers infringing on our pieces of arithmetic. Okay, so again, some rules on divides. For any whole numbers A, B, and D, D divides A, D doesn't divide B, and A is greater than or equal to B. Again, this is just to keep the negatives out of our way. Then D will not divide the difference of A and B. All right, so in other words, if D is going to divide a difference, it has to divide the individual numbers that are involved in the subtraction. All right, some more examples for us. And again, we're back to true, false. If 4 divides X and 4 divides Y, then 4 divides X times Y. Well, again, guess what? As long as I know 4 divides X, I don't care what you're doing with Y. 4 doesn't even have to divide Y. 4 will divide the product of X and Y. So that one's true. Number 11, if 3 divides the sum of X and Y, then 3 divides X and 3 divides Y. Now, this is a sneaky one because if we did the other premise, if we knew that 3 divided X and we knew that 3 divided Y, we could draw the conclusion that 3 would divide the sum of X and Y. But as this is written, I think we're in trouble, right? The fact that 3 divides a sum doesn't mean that 3 will divide the individual numbers involved in the sum. Pretend for a second, just pretend x is 1 and y is 5. 3 would divide the sum of 1 and 5. 3 would divide 6. But 3 doesn't divide 1. 3 doesn't divide 5 either. So I think on number 11, we're going to have to kick into false. All right, number 12. If 9 doesn't divide A, then 3 doesn't divide A. That's another sneaky one. Think about a number like 15. 9 does not divide 15. But you know what? 3 does. So the way number 12 is phrased, I think we're going to come back false. So a lot of true falses, just try to get a handle on this divides idea. Think about some things, send me some questions if you still need some more examples. And that, my friends, is the end of video 1 for Unit 5. We'll be back soon with video 2. See you then.